All right, so we got the big sheet of steel cleaned off. And one thing I forgot to point out, the first part of this was make sure you're wearing grungy clothes, because now I've got to hide from my wife when I go inside when she realizes I just totally hosed a pair of good jeans. So anyways, what I did, I came back and I used my pattern and I just, like I said, I traced it out. Again, this was a 3D modeled paper pattern that I cut out and made it into a 2D form. So I basically traced around that, flipped it over, lined things up, traced around that. So now I have the entire jaw section. So these ends I left a little bit long. That's going to be a weld point, so I wanted a little extra metal here. These I'll actually cut probably an extra 1/4 inch to 3/8 of an inch long, just because that's where these get folded over and they get welded from the bottom side. So for one thing, as you weld something on the end, you don't want the pieces of metal to melt out, so you leave it along. Plus, they're not going to line up perfect, so I want a little extra metal so I can come in here and grind these to the perfect contour I need. And along the bottom edge, obviously the Noble 6 helm doesn't end in a sharp thing. It has the kind of a 1/2 inch, 3/8 inch flare. I'm going to come back in with aluminum. I'm going to make a rigid kind of frame for that. This will then fit down on, so that's going to help me hold the whole helmet to the shape it needs. Otherwise, as you start welding things pull in from the heat, they twist, they warp. So to counter that, I'm going to have that aluminum lip along the bottom edge of it made with probably 1/4 inch by 3/8 inch aluminum bar. Now we're going to take this and we're going to cut this piece out of Beverly shear. Again, you see this makes short work of 16 gauge. And for those wondering what 16 gauge, this is about 0.57 on this particular sheet. When you buy 16 gauge steel, it actually can go anywhere from like 0.52 up to 0.60 something. So not all gauges are the same. It's a nominal dimension. So what's nice about aluminum, if you buy aluminum, you buy it by the actual decimal equivalent call out. 0.50, 0.63, 0.70, and it will be exact dimensions, where cheap steel, cheap mild steel, you get 16 gauge, 14 gauge, 18 gauge, they're all plus or minus a little bit. You become a contortionist learning how to use sheet metal and a shear. Things you always want to watch for is if it starts to fall, you have to get out of its way, because the metal is sharp and you can really cut yourself bad.
So you have.
So now I'm going to go back. I'm going to trim it to the exact line there. I'm going to give myself a 3/8 inch lip along the exact dimensions there. Then I'm going to come back with an angle grinder, cut out these little slits in here, and from there I'll take a scribe and I'll scribe these lines, because as I start shaping this, these lines are going to disappear. So I don't want those lines to disappear and me be sitting there going, oh my god, where were they? So I'm going to come back and actually scribe it into the metal. Deep enough I can see the marks, shallow enough they're going to come out with sanding in the end anyways, sandblasting, painting, they'll be gone in the final product. I did armoring for 4 years before I bought one of these. If you plan on doing sheet metal work, man, these are nice. don't know what they cost now. This is the B1. They come in 3 versions, B1, 2, and 3. They can cut successfully thicker metals. This is the B1. I think I paid about $360 for it back in 1990.
A couple of years before I was born.
92, 91, 93. I started doing this in 90, yeah, about 93. So again, they're pretty cool. And you got to sharpen the blades every now and then, but they're pretty neat machines. Anyways, now I'm ready to scribe these lines, basically scratch them into the surface and start shaping.